This is part 4 of the bicycle wheel tutorial. In part 3 we got all the way to step 32, which gave us a full complement of spokes and a completed hub shell for the front wheel, which included the axle area, the flanges for the spokes, and the area that contains the bearings. For this part we will complete the front wheel by adding the rim, including holes in the rim for the nipples to pass through, a hole for the stem valve, and then we'll complete all the features that go into the hub, which includes the axle with a metric 10 thread on it and the spacers that go into the bearing area. So I'm going to roll the model back to step 33, which is the revolve that creates just 1/2 of the rim. So now I'll roll back before that so we can recreate this step. What I'm going to do is turn on my sketches for the typical rim cross section and the rim inner diameter. Let's take a look at the rim cross section. This is your typical cross section of the end of a rim, which includes the feature that clinches onto the tire, 19mm width, which you will not be changing, an 11mm sidewall. And a classic bicycle rim tends to have a little bit of a crown to the inside of the rim. This would be a traditional shaped rim, and you can go ahead and use this, but you can also customize this by making it more of an aerodynamic shape if you like. So what you'll be doing is borrowing these features, which must remain unchanged, and then adding more shape to it if you like. A lot of bikes utilize this flat surface as a brake surface. If you would expect your bike to eventually have brakes on it, then you want to leave this area flat and then add the aerodynamic portion out here. If you don't expect your bike to ever have brakes, or perhaps would have disc brakes, you sometimes find rims where this surface here is not flat and is just part of the overall curved rim. You can do whatever you like, but you need to maintain this inner shape here and these shapes here. Now zooming out a little bit, and taking a look at the rim inner diameter, this dimension controls the depth of the rim going from the outer edge of the rim to the inner diameter. A deep aerodynamic rim would have a large number like 50. A more traditional rim would have a much smaller number like 11 or 12, and would end up, if you want to have a crown to the top of the rim, matching the crown. This is a number that you will set, and this curve here, this inner diameter, will end up controlling the shape of your rim in this area, which I'll demonstrate in a few moments. So going back to our top plane, we will start a new sketch. This is step 33 we are now working on. From the top view, what I'm going to do is copy these portions of the rim, and then I'm going to add on the additional profile that I want to have. In this case, I've decided I want to have an aerodynamic rim, which will have a sort of teardrop shape in this area. Using convert entities, I will copy these portions, and then what I'm going to do is add the curve that will complete 1/2 of the shape of the rim. I'm going to drag this back to here. A lot of rims if this area is flat, they actually have a little bit of a step before they go to the aerodynamic portion. That's because this area is machined so it's nice and flat for the brakes. So I'm just going to add a short step here. I'm going to tilt this so that we can see that sketch that controls my inner diameter. So this was a decision I had to make earlier as to what this appropriate depth was going to be, because this also controlled how far out the spokes came on the wheel. So I'm going to just draw a line here. Then I'm going to draw something simple like an arc. I may need to make sure that this line comes out to this inner diameter. So I'll just take this endpoint and this line and make a pierce relation. And I'll make the width of my rim somewhere about 4 millimeters here. Actually, it'll be 8 millimeters once it's mirrored. And I think I'll add a horizontal sketch line here, construction line, and just make these two tangent. Drag that inward. And I said I was going to have just a little step here, maybe 0.5 millimeter. So typically what you find on a rim is this area is painted or anodized, and this area here is machined and left free and clean for the brakes to rub on. Then I'm just going to complete this by adding a line here to here. Let's turn off all my sketches. So now we can see what the profile of 1/2 of my rim is going to look like. We copied these details and we added these parts on, and this part has a pierce relation to the inner diameter or the rim sketch, which is this sketch here. All we have to do now is revolve this around the center axis. Now in a real rim, this area would be hollow also, but we are simplifying this a bit and just leaving this as a solid chunk because we're not going to be seeing this interior anyway. So all I have to do now is add a center line going from the origin out to here. Go ahead and revolve that. That gives us 1/2 of the rim. Now this is a pretty extreme depth. Usually a rim that has this great a depth to it has fewer spokes. So you might want to make yours come not quite so deep. And there are other shapes you can consider. Some are fully rounded over on the top. Others are kind of more triangular shaped. They don't have to have this rounded side. So this is your opportunity to do a little bit of customization. I've gone ahead and changed the color of the rim body to something other than the same color as the spokes to help me see it a little bit better. And I'll use that opportunity to mention that when you revolve the rim, leave it as a separate body. In other words, going back into the feature here, leave merge result unchecked. Now for steps 34 and 35, we'll just add some fillets if necessary. Depends on what you need for your rim. So I added a fillet here at the top edge and another fillet to remove this sharp edge that otherwise would have been on the outside edge of the rim. The next step then is just to mirror this rim body, and again this is an important reason for keeping this as a separate body. So we will simply use the mirror command, and on the front plane use that as our mirror plane, and the body we will mirror is the entire rim. And if we use merge solids, what it should do is merge the rim only to, it'll merge the copy of the rim only to the original. It won't merge it to any of the other features that it might at the moment be intersecting. So there we have the full rim. It still has remained as a separate body, even though we used the merge, because what it did was it merged the one half of the rim with the other half, but left it unmerged from the spokes. So we can see here that the nipples for the spokes just sort of disappear into the rim without any sense that there's actually a hole that these enter into. You can see there's no hard edge indicating the end of the rim where a hole would be for the spoke to go into. So what we're going to do is add spoke holes and pattern them. So you can see here a definite sharp edge where the blue of the rim ends, and a hole that allows the end of the spoke to enter. So let's go ahead and roll back these features and recreate them. What we need to do is create a set of holes around the perimeter of the rim that matches the same spacing as the holes of the spokes that are entering the rim. To do this, we need to go back to our spoke layout sketch because this controls the location of all of our spokes. So let's turn on that sketch and hide the others. Zoom in here. You recall that the layout sketch for the spokes gave us the locations of just the first two spokes, an outer spoke and an inner spoke. What we are going to do is just make one hole going through the rim that is aligned with this outer spoke, and then just go ahead and pattern it 28 times around the perimeter. We don't need to add this one because this one will be on the same spacing as all of the other spokes. So just one hole patterned 28 times will give us everything we need. So going on our front plane, what we want to do is make a hole that has an axis which is radial with the center of the wheel, even though the spoke enters the rim at a slight angle. All the spokes enter the rim at different angles, so what we are going to do is just have a hole radial to the center, and we'll oversize it a little bit to allow these spokes that come in at a funny angle to be able to get into the hole. In fact, that's the way it's done on an actual wheel. So we will make a sketch on the front plane. Actually, we've already started our sketch. We're going to copy this line from our spoke layout sketch. This line goes all the way to the center of the wheel, radiates outward, and goes to the rim where this spoke enters it. So convert that entity. I'm going to change it to a construction line. I'm going to hide all my sketches. I'm just going to drag this out where I can see it a little bit better. What I want to do is revolve a hole that is centered on this construction line and make it big enough for the nipple of the spoke to pass through. The nipple is 4 millimeters in diameter, so we'll purposely make the hole a little bit bigger so that this funny angled nipple will be able to enter and have clearance on both sides, even though it's not completely in line with the hole itself. So I will just draw a rectangle here that has one edge on my center line. Make these lines perpendicular. Let's turn on our relations. What I want to do is make this hole a diameter of 4.25 millimeters, so that'll be a little bit larger than the nipple. I'm just going to drag this way out here so you see that this is well beyond the inner and outer diameter of the rim. Then I'm just going to do a revolve cut. I need to make sure that this cut only cuts the rim. So I want to go to my feature scope, open that up. If all bodies or auto select is selected, unselect that, have selected bodies checked. That will open up this box here. We are going to select the rim to be the item that will have the hole put into it. So now we have, for step 37, our first spoke hole. All we have to do, we see that even though this is entering at a funny angle, we made the hole just a little bit bigger so that it doesn't bind up. We see that these side surfaces do not bind up as they are entering this hole. Now it's just a matter of patterning this around the entire rim. We remember that we have 28 spokes, so we need 28 holes. So we are going to pattern this revolve cut, in other words the hole in the rim, about axis 1. Selecting circular pattern, axis 1, revolve cut is already popped in here because I pre-selected it. We need a total of 28 holes. We can see in the preview how the holes are aligning with the spokes. We go ahead and finish that. And here we see on every spoke there is a matching hole. So we have to make sure that the total number of holes patterned matches the total number of spokes. So later on when we go to change configurations to the rear wheel, we're going to have to change the total number in the pattern to match the spokes that we're going to put into the rear wheel. So we've just completed steps 37 and 38. Step 39 is to add the hole in the rim that the air valve stem is going to pass through. If you look at the way the spokes are arranged, as I mentioned before, they tend to clump in clusters of 4 spokes. It's always desired that the valve stem go between the 2 spokes which are approximately parallel to each other, because this gives more room to get your hands inside when you're trying to pump up the tire. What I've done is made a sketch that automatically puts that valve stem in the proper location between the spokes. So all you have to do is use this sketch to make a revolved cut which will give you the hole that this valve stem will pass through. And this will automatically be aligned regardless of the number of spokes that you choose for your wheel. So let's get out of here and roll that feature back so we can recreate it. So what we're going to do, I'll zoom in on this area so we know that the valve is going to go here. Turn my sketches back on. We can hide the spoke layout sketch and make visible the valve stem hole locator sketch. And on our front plane, make a new sketch. We're going to take this center line and copy it into our sketch. Let's drag this out a little bit so I can see it out here. Turn this into a construction line. Let's go ahead, hide our sketches. And like before, I'm going to draw a rectangle. Just drag it out here somewhere so that it's well beyond the bounds of the rim. And I'm going to make the hole 1/4 inch in diameter. That's the same thing as 6.35 millimeters. And once again, we're then just going to go ahead, make a revolved cut. There's our hole for the valve stem. So we're coming down to the last few features of our wheel, steps 40 through 43, which I'll just slowly roll through, and then I'll go back and recreate each one. Step 40 is to be adding the bare axle and the spacer. Step 41 is going to be to add a single screw thread onto the axle. Step 42 is going to be to pattern those screw threads. Step 43 is going to be to mirror the axle and spacer body to complete the other side, and that will complete the entire front wheel. So rolling back before step 40 so we can recreate these steps, what we want to do is have our hub cross-section layout, our hub bearing area layout for the front wheel visible. So looking from the right plane, we can see the sketch for the axle passing through and the spacers that go into the bearing area. What we are going to do for step 40 is to revolve one half of the axle out to the center of the wheel and at the same time revolve the spacers. Now the axle has threads added to it, and we have in our layout sketch a representation of one single thread. When we revolve the axle, we are going to revolve the smaller diameter of the axle, not the outer diameter that includes the tip of the thread. Later, we are going to glue the threads on and pattern them, which will bring the axle up to its full diameter. So now, beginning step 40, new sketch on the right plane. I'm going to copy several of these lines using convert entities. I'm going to copy this line, not this line, this one. There's one here that's difficult to see. And we can go ahead and copy this center line here. Actually, we'll just leave that alone. I'm going to hide all types, and I'm going to add a line here, a vertical line here at the middle of the wheel. I'm going to take this line, which represents the axle, and drag it all the way out to here. Now it's time just to do some trims to get rid of some of this excess material. So we'll get rid of this, these lines here. There's a line up here, and a line down here, and this excess material here. So let's take a look at our situation. This represents the axle portion going through the hub. This represents the spacer, and we're going to revolve this. So going ahead to our revolve, pick this as our axis. And this is going to be, as you can see, the axle and the spacer. We want to leave this unmerged. I don't think it's going to merge with anything anyway because it's not actually contacting anything. So there we have the axle and the spacer, and now what we want to do for step 41 is start adding these threads onto the axle. In reality, the axle and the spacer are two separate parts, but we're just going to treat it as one part for the simplification of this construction. Let's take a look on the right plane again. We'll zoom back in, turn our sketches back on. What we want to do is add just one single tooth for step 41. So on our right plane, start a new sketch. We are just going to copy this one triangular tooth profile. So using convert entities. We're going to revolve that about an axis passing through the origin. Let me go ahead and hide all types so we can see what we've got here. So here's our axis, and this tooth is going to be revolved around the shaft of the axle. So we're going to be gluing this tooth on using revolve. We're doing this as a separate feature from these revolves because we also need to pattern this going in this direction. So now all we have to do is pattern this over. But before we do that, let me talk for a minute about what it is we're actually making. We are going to be making an axle with a metric 10 thread that has teeth that are spaced at 1 millimeter apart. This is what we call an M10 by 1 millimeter thread. English threads give us the teeth in threads per inch. Metric threads just tell us what the spacing is between the threads, which is actually more convenient for our purposes. So we're going to go ahead and pattern this in this direction. I'm going to use a linear pattern we're going to pattern this along axis 1. The feature we are going to pattern, now we're patterning a feature, is our one thread. You want to reverse the direction here so it's going this way, and the spacing between threads is going to be 1 millimeter because this is an M10 by 1 millimeter thread. So we're just going to keep adding threads onto this until we fill out this whole area. Now it might turn out for the rear wheel that we need more threads for the longer axle. So if we later on change to the rear wheel configuration and find that the threads aren't going far enough, we might have to go back and change this number. For now I'll just leave it at about 21. And you see that these threads go all the way into the body of the spacer. We won't bother with threading all the way to the end here because no one's going to be seeing that anyway. So completing this, there's our threads. So now we have a body that includes the axle, the threads patterned on it, and the spacer. Our final step, step 43 then, is just to mirror this body, and that will complete the front wheel. So going to mirror, we will select our front plane as the mirror plane. This time we were going to mirror a body, which is this body that we just created. We want to choose Merge Solids. It's only going to merge the newly created body to the one that it was mirrored from, not to any other body. That completes the wheel. But before we're completely done, because we kept these as separate bodies, we can easily give them different colors. So for example, it's typical to find the axle and the spacers on a wheel to be a darker black or charcoal color. So I can just go to this body here, which represents the axle and spacers, right click, go to Appearances. I'm going to choose the body. That opens up a palette here, and I'll just choose a color like this or maybe like that to give me that darkened axle and spacers, which makes this look a little bit more realistic. Also, by keeping the rim separate, you saw earlier that I had changed the color of the rim, but I didn't really show how to do that at the time, so I can give the rim a completely different color, which you often find on bike wheels, is that the rim might be an anodized color even though the spokes and the hub are chrome. So this concludes part 4. In part 5 we'll show how to add the features for the rear wheel, which will complete the wheel part altogether.